Newton-Raphson formula for the qth root to derive the iteration formula to compute the qth root of a number m, and then use it to evaluate what the fifth root of 43 correct to 3 decimal places with x naught it is equals to 2. So the first thing that you are going to do when this question is given to you is that to find the qth root of a number m, I have to say let x be equals to what? Be equals to the fifth root of what? The fifth root of 43. And this can be rewrite as, if I take the fifth root of both sides, I'll have fifth root and I will have fifth root. Fifth root will cancel fifth root. At the end, I will left with only x raised to the power of what? X raised to the power of 5. It is equals to what? Only 40 what? 43. So therefore, and also this is implies that x raised to the power of 5 minus what? Minus 43. Minus 43 equals to what? Equals to 0. When this positive 43 would cross that equal sign, it will become negative, and therefore I will equate it as what? As 0. The function f of x should now be x power 5 and also minus what? Minus 43. And therefore I'll find the f prime, which is the derivative of what? Of the function. If I differentiate x raised to the power of 5, I'll get 5x power 4. But if I differentiate 43, derivative of constant is 0. So the formula for what? For the Newton-Raphson method is what? It says x of n plus what? Plus 1. It is the same thing as it is equals to x of n minus what? Minus f of xn, and also divided by f prime of what? Of xn. This is prime. And therefore this will now be equals to the x of what? Of n minus the f of x of n, which is the first function, which is x raised to the power of 5 minus what? Minus 43. And also I will divide it by the derivative that I differentiate, which is the f prime of what? F prime of x, which is s power of 4, and what? And I have what? I have n. So therefore the x of n plus 1 should now be equals to, all the way, this is the same thing as divided by 1. I have the LCM. The LCM, which is also 5, which is 5x raised to the power of 4 as a subscript of n. So if I set this into 1, it will give me the same thing, which is that 5x power 4 of n. So I have to multiply it with what? With this 5x of n. So therefore, if I multiply it, I'll get 5x what? 5x raised to the power of 5 of what? Of n, and then I have to say subtracted by. If I set this into this, I'll get 1. So therefore, if I subtract 1 by the what? By this, I'll get only this. S to the power of what? Of 5 with the subscript of n minus 43. And this is the same thing as, because they have the same power, so I can easily subtract. So as soon as if I subtract them, I'll get what? I will get 4x power 5 at the subscript of n, and then sorry, this I have to put it in bracket. I have to say minus, sorry, this is in bracket, this is in bracket, and therefore when you distribute, this will not change, it will become positive. So this will now become positive what? Positive 43 divided by what? Divided by 5x power 4 of what? Of n. So therefore, the next thing that we are going to do, we are going to find the iteration, first iteration, second iteration, afterward, after the point that we will have the same when two iteration are equal. So therefore, I will say, let's say first iteration. Let me say iteration 1, but when n it is what? When n it is equals to what? 0. And also from the question they says they give us when x naught it is equals to 2, this is 8. So therefore from the first iteration, when n it is equals to 0. So therefore 0 plus 1, it is 1. So therefore I will say x what? x1, it is equals to what? I will say 4, but when x it is equals to 2 from the question. So I will now say reciprocal of what? Of 5, and therefore plus 43, and also divided by 5 multiplied by what? By 2, also to the power of what? To the power of 4. So let me see what shall I going to get. So therefore at the end I'll get 2.137 what? 75 as what? As my value of x1. So therefore I will move to second iteration. So let me say, but in iteration 2, n should now become 1, because iteration 1 n is 0. So therefore I will now say x2, it is the same thing as 4 multiplied by this 2.1375, rest to the power of what? Rest to the power of 5, and therefore plus what? Plus 43 divided by what? Divided by 5 multiplied by 2.1375, rest to the power of what? Of 4. So let me see what should I going to get. So at the end I'll get 2.206 what? 65 as what? As my second iteration. So therefore I am moving to iteration 3. So moving to third iteration, when what? When n it is equals to. So moving to the third iteration, when n it is what? It is equals to 2. And our x2 is this. So therefore it will now become x3. Let me say x3, it is the same thing as 4 multiplied by 2.2065, that's the power of 5, also plus 43, and divided by 5 multiplied by 2.2065, rest of the power of what? Rest of the power of 4. So let me see what we are going to get. So at the end I'll get 2.1234. So let me move to the fourth iteration, but in fourth, okay, let me say, yes, fourth iteration. In fourth iteration, I will say when n it is equals to what? It is equals to 30. So let me say when n it is equals to 30. So it will now become x4. So x4 will now be 4 multiplied by 2.123, 4 power 5 plus 43 divided by what? By 5 multiplied by 2.1234, rest of the power of what? Power 4. Again, what should I going to get? The value of x4, which is 2.1218. Yes, I think it's 8. Yes, approximately. But don't forget, this is n3 when n it is equals to what? When n it is equals to 3. So now we are going to perform the fifth iteration, iteration 5. So from iteration 5, when n it is equals to 4, when n it is equals to 4, iteration what? Iteration 5. So therefore this should now be the x of what? X of 5, it is equals to 4 multiplied by 2.1218 raised to the power of 5 plus what? Plus 43 divided by what? 5 multiplied by 2.1218 raised to the power of what? Of 4. What should I going to get? So this is the same thing as 2.1217 what? 75. So therefore, as you can see, both x4 and x5 are equal to what? Are equal to, both the x and 5 are equal to 2.122 approximately, because this is my x4. If I approximate it to 3 decimal places, I'll get 2.1 point what? 0.1, and also this 8 will add 1 to this one and it will become 2, and also this 7 will add 1 to this 2, it will become 2.1 what? 122. The next thing that you are going to know is that whenever, if you press in calculator and says what will be the what? What will be the fifth of 43? The fifth root of this 43 to 3 decimal places, so you will automatically get 2.122. If you round it off to what? To 3 decimal places, you get 2.122, and also we get 2.122 in our iteration. So therefore, this is what? This is a solution of what? Of this Newton-Raphson formula for the qth root.